Stoichiometry. Stoichiometry is chemistry's central concept. It allows you to figure out if you want to make a certain amount of product, how much of your reactants you're going to need to use. The way we work stoichiometry, we have a one-way street. We can start with either grams or moles of one substance. It could be A, B, C, or D, doesn't matter which one. We use the molar mass to convert it into moles. We use the ratio of the coefficients in the balanced equation. For example, this might be 2, 1, 3, 4. We use those coefficients to convert from moles into moles, and then we use the molar mass to convert back to grams again. Again, this is a one-way street. You can start at either grams or moles, and you can end up with either moles or grams. So sometimes you don't need to make the whole trip. If you start here and end here, you don't need to worry about the other two conversions. In my template that I've written here, if you see something below the yield sign, it means you will be dividing by, in this case, the molar mass. In this case, you will be multiplying by the molar mass. Now, in a balanced equation, and here's my sample equation, this tells you the ratio, that's a 1 assumed. This tells you the ratio of the number of molecules that react with each other. And these are written in either single molecules, or what is actually more useful is moles of molecules. So, for example, we can write a variety of mole-to-mole conversion factors. For example, 2 aluminum hydroxides will react with 3 sulfuric acid molecules. Or we could rewrite that equation as 3 sulfuric acid molecules will react with 2 aluminum hydroxide molecules. We could also say that 2 aluminum hydroxide molecules can produce 6 waters, or that 6 waters are produced when 2 aluminum hydroxide molecules react. So there's a lot of different mole-to-mole factors that we could write. Also, if we happen to start with 6 molecules or 6 moles, we would need 9 molecules or moles of sulfuric acid, 3 molecules of aluminum sulfate would be generated, and 18 molecules of water or moles of water would be generated. So that's what we're looking at these factors. You've got the same ratio. A 2 to 3 ratio is the same ratio as a 6 to 9 ratio. Usually before you get started, you may want to know the molar masses of the compounds involved. I've previously calculated these, and notice this molar mass of 78 is the molar mass for 1 mole of aluminum hydroxide. Not for 2 moles, but for 1 mole of aluminum hydroxide. The molar mass of aluminum, and then 3 times the 16 and 3 times the 1. Adding that all up together, you should get something close to 78. Now, in working with stoichiometry, you need to know where you're starting, where you're finishing, and you need to know those units. So this is telling me if I have a half a mole of water, or if I've produced a half a mole of water. And what I like to do is write down the balanced equation and put my information on top of each substance. So the half a mole of water is what I know, and I want to determine how many moles of sulfuric acid. So this tells me if I'm looking at my whole template, I only need to go from moles to moles. I need to do one step. So I will write down the information given, and at this point I need only my coefficients as my conversion factor. I'm in moles. I want to get rid of the water, and I want to turn it into sulfuric acid. And there are 3 sulfuric acids for every 6 waters. So I've got 0.5 times 3 over 6, which is actually reduces to 1/2, but I do want to put in the 3 and the 6. So we'll actually have half that. So I would need 0.25 moles of sulfuric acid. Now if you look in the textbook will add moles at both of these points, which is probably more correct. I tend to minimize what I need to write, so at this point I simply need to write the coefficients and the label, because actually what I am canceling out is the label. And if I look at the units, what the units I should have left would be moles of sulfuric acid. Okay, that's a mole to mole conversion, which is the simplest one. The next one, we are given the moles of aluminum hydroxide, and we want to know how many grams of sulfuric acid are also going to be used. In order to use up all the aluminum hydroxide, how many grams of sulfuric acid do you use? Well, my starting point is moles and my ending point is grams. I'm going to need 2 conversion factors. I'll need coefficients and I'll need the molar mass. And by the way, the molar mass of sulfuric acid is 98 grams per mole. So my starting information is 0.35 moles, and notice I'm also going to put down the label. I've got a unit and I have a label. Now because I'm in moles, I'm ready for the coefficients, which means I'm going to change substances. I'm going to use the ratio from the balanced equation to change substances. And this is a 2:3 ratio. And what I have done is canceled out the aluminum hydroxide. And now I need to put my moles of sulfuric acid into grams. And there are 98 grams in 1 mole. Now, when I do this on the calculator, I'm going to multiply by everything on the top. 0.35 times 3 times 98 equals, and then I will divide that by 2. And I will get as an answer 4.725 grams of sulfuric acid. Because I started with 2 digits, I'm going to round that off to 4.7 grams of sulfuric acid. The coefficients are exact numbers, so they do not relate, they do not enter into significant digits. And here you should probably have 4 significant digits if you use the atomic masses in the front of your textbook. Okay, next example. For the next example, I'm starting with 35 grams of, whoops, wrong place, 35 grams of aluminum sulfate, and I want to know the number of moles of water. So I'm starting with grams and going to moles. I'll write down my initial information. And because I've got grams, I've got to get rid of those grams right away. And if you remember from a previous slide, the molar mass of aluminum sulfate was 342. I've gotten rid of my grams. Now I'm going to get rid of my aluminum sulfate and turn it into water. And this is a 6:1 ratio. And now I'm going to stop, because what I have left is moles of water. Again, if you look at your textbook, you will see that they will put in the label here and here, and they will put in moles here and here. And I have eliminated those just to make these a little bit shorter to do. Now putting this in your calculator, again you'll multiply by everything on the top. 35 times 6 equals, and then I'm going to divide that by 342 equals. And I get 0.61, and that is moles of water. And 2 significant figures is probably appropriate here, so I'll just leave that there. The last example that I have is a gram to gram conversion. I'm starting with 0.62 grams of sulfuric acid and converting it to grams of aluminum sulfate. So I'm given 0.62 grams, and I want to know the number of grams here. Molar masses, and I'll put those in. We figured those out earlier. I'm starting with 0.62 grams of sulfuric acid, and I immediately want to get rid of those grams. There are 98 grams in a mole. Now I can get rid of the sulfuric acid and put it in terms of aluminum sulfate, and that is a 3:1 ratio. I've gotten rid of the sulfuric acid. Now I will convert those moles of aluminum sulfate to grams by multiplying by the molar mass, 342. Now to do this, again, I'm going to multiply by everything on the top. 0.62 times 342. I'm going to divide that by 98. Push equals. I don't think I did that right. Let me clear that. 0.62 times 342 equals, divide that by 98 equals, and then divide that by 3. And I get 0.72. This is grams of aluminum sulfate. And again, these moles cancel out. The units that you have left are grams and aluminum sulfate. So the important thing is to know where you're starting and where you're finishing. You don't need to do the whole process. And if you followed on the sheet and wrote these down on the handout, you should have a template for doing some more of your problems.